Hey, Networking 101, much better in gym class. You know, who would have thought, right? Some of the biggest changes you're going to see in the next 5-10 years going to come from this. And not actually from the output of it, but I'm talking about the graphite in here. There's this really cool substance out there, and it's called graphene. And I really want to introduce you all to what it actually is. You'll hear a lot of stuff out there, but we're starting to make some real advances, not only in physics, but also in the science of how we're integrating this stuff into networking equipment, that I want to introduce you to the product, or not really the product, but the science of graphene, what it is, what it does, and we'll rock it from there. Now, graphene itself is basically, when you look at it from a physics perspective, it's really like this lattice of atoms that connect together that look an awful lot like chicken wire. You know, to be honest with you, it's six-sided, and we're connecting all these devices. Let me change my pin color here. We're connecting them here with just a small bond at each one of these junctions, and we're carrying it out all through this great big huge architecture there. Now, what does that really mean? Well, we've had it around since the 1800s, right? We've known about it, it's been there, but there really hasn't been a real advantage to what graphene does. It's kind of one of those things where, oh, imagine that, it conducts electricity, pencils, how cool. Remember if you ever did like a science experiment, a lot of times you could like color and you'd make really dark lines, and you could hook like a battery to it, and then you could actually run like a small light on and stuff, be like, whee, you can draw your own circuits and stuff. It's more true than you think, because see, back in the year 2000, or actually 2004, these two dudes here, I'm going to absolutely butcher their names, Andrei Glean and Konstantin Novoslav. I apologize, dudes, if you watch TechWise TV, oh my gosh, how cool is that? But if you know these guys, then please, my apologies and stuff. They actually said, hey, you know what? This graphene stuff's pretty groovy. They were studying something called carbon tubes, and they said, you know, I bet you if you could take the pencil lead, this graphene, and make it thin enough, you could really have this really cool substance here. And you know how they did that? They were like trying to figure out how to make this thin, because we knew it worked. But how do you make it small? How do you make it thin? Because electronics, electricity, we want to keep getting smaller and smaller, right? I mean, everybody pull out my phone here and stuff. I mean, everybody wants smaller phones, smaller devices that do more. Here's Rob's 4G router here. I mean, imagine how big that would have been years back. Smaller is the key to doing this out. Now, what graphene did is that they were laying those pencils out, and they're saying, hey, you know what? What if we take some tape and we just keep, putting it down on paper, and we keep peeling it off, and then putting more tape on that and peeling that, and more tape and peeling, till we finally have something small enough, and let's see if it conducts. And you know what? They actually did this, and they won the Nobel Prize for this actually in 2010. These dudes won the Nobel Prize in physics for their work on graphene, and their tape dispenser and their lead that they use, or graphene, is actually in the Nobel Museum, because the breakthrough was so simple. It was done with these two items here. And what they did is that they made this graphene 1 atom in size. That's how big this is, 1 atom. Now, turning Networking 101 into Physics 101, what is an atom? How small is an atom? If you look at, to get you some representational size of this, let's take like a standard grapefruit. And we say, okay, this is a grapefruit here on my table. And if I took a grapefruit and I said, hey, you know what? What if I just blew up just the nitrogen, the N2 atoms in here, because it's smaller, we'll use that and stuff. If I blew up the N2 atoms as big as a blueberry, now I'm going to use a green blueberry in here because I eat kind of weird stuff. So if I just blew up just the nitrogen atoms inside of this single grapefruit as big as a blueberry, that grapefruit would be as big, if not a little bit bigger than the planet Earth. That's how small an atom is, right? That's how small that they got this down to. And it conducts, right? And it not only conducts, it actually speeds up stuff so incredibly fast, it is unreal. How fast? Well, what we did is that recently, a couple researchers at University of Cambridge, they said, hey, you know what? What if we made some photoreceptors, and we said, let's make those out of graphene, and let's put those into an optical switch. Because we'll use optical switches like for high-speed internet transfer, that type of stuff. Why? Because they're lightning fast, right? How fast? about 2 picoseconds is our transfer rate for standard optical switch. That's why they're expensive, right? They're, $500,000 is kind of the starting price, and every sales rep wants to sell them because, oh my goodness, man, does that retire the series quota? But, and that's what you need to actually transfer that data that quick. They successfully built some graphene phototronics in here, and the speed went from, let me go ahead and change my pen here and stuff, it went from 2 picoseconds over here to 100, here's a new term, maybe, femtoseconds. Now, once again, what is a femtosecond? A femtosecond is abbreviated FS. It's about 1/4 of a second. And to actually break that down in perspective, if I said that, okay, if a femtosecond equaled a second, then 1 second would equal about 31.7 million years. That's how small of a time fraction that is. Can you imagine how fast that data transfer is now? That's why this is a massive, massive, massive breakthrough. And the UK is actually leading the charge here. If you're interested in graphene research, this is certainly going to be the next big thing. I mean, it is really, honest to goodness, a big thing. University of Bath, Manchester, they're doing some really darn cool stuff with graphene. IBM is really on the forefront of designing stuff optically with graphene to really change some stuff. And it's incredible. I mean, the things that we're going to see in the next 5 years with graphene, that's some good stuff, man.